Hi, everyone. Welcome to today's community call, another one in a row. I'm Ata from the developer experience team here in MemGraph, and I'm excited to see you here for a really special session on building a RAG app on an MCP-based architecture. So today we are joined by Rida and Affan from the Orbis company. It's great to have you both here, and thank you for coming. Rida and Affan have been building a large-scale question answering system on top of memory. So previously they used a classic LLM to Cypher to execute pipeline, but that of course has its challenges, especially when dealing with some messy data, messy real world data. So now they moved on to the MCP-based architecture that completely changes the reliability of the application. Now, before we begin, just a quick note that we have a chat here, so feel free to chat with each other, ask any questions you might have during the presentation. And we're going to have a Q&A session at the end where Rida and Afan are going to answer all of those. So yeah, I think that's pretty much it. I'm really looking forward to hear about the improvements and challenges and all of the behind the scenes of how you guys use the MCP for your product. So with that, I'll hand it over to you.
Thank you, Mattia, for this really good introduction. I will share my screen. I'm Rida Shah. My colleague is Affan. We are from Orbis Holding company. And so let me share my screen. You see my screen?
Yeah, we can see it.
Very good, perfect. So in this presentation, we are going to speak about our experience on building a GraphRag application on an MCP-based architecture. So me is Rida Chall. I am a senior AI engineer at Orbis Holding company. We work on a multi-domain biometric solution. We work also on an NLP task and on large language model pipeline, and recently we are working on MCP-based approach. So, and here is also my colleague Affan Abbas.
So, hi everyone. I'm Affan Abbas, data scientist at Orbis Systems. I've been doing the MCP integration work on our GraphQL system, focusing on our Cypher query generation, error recovery with LLM-driven connections. In my part of presentation, I will explain how MCP fits in our architecture, the challenges we've solved, the improvements we made, and moving to the MCP-based design. So now I would like to call Ms. Rida to continue with her part of presentation.
Thank you, Affan. So here, what we are going to speak about, what is the context of our QA system or of GraphRag system. Then I will explain why the old pipeline architecture, the LLM to Cypher, then to execute failed. What are the limitations? What are the challenging? So next we move why we have adopted the MCP approach, how this MCP approach is able to handle our real data, how it's able to handle multi-hop reasoning approach, and we are going to compare at the end the both architecture to come up with a conclusion and what we are going as a future step for improve our MCP-based approach. So let's start with our context. Actually, what we have a memgraph database that contain large number of nodes and edges. We don't have just 1 million. We have about 100 million of nodes about person, vehicle, company, document, and many more entities. Our goal actually is to build a system where we are able to extract information related to a person and its related properties or its related relationship. So the user is able to ask any natural language queries or questions, and he should receive an answer in natural language approach. So this is a basic QA approach system. We start with the pipeline-based approach, where we build a graph-based system or more chain-based system, where we have a user questions. Then we construct our prompt around the the user query, and we provide as extra some schema context, and we pass this to LLM to generate the cipher. After generating the cipher, we pass it to a quick validation, just the explain approach. And then later on, we go to memgraph to execute the cipher. And here we can have either some response, or we can have no response, or we can have error. So here we have three different cases. In case if we have a response, we go directly to the LLM to generate natural language processing answers. Or if we have no answer, we just tell the user that no answer we have about this question. And if we have any kind of error or exception, we have this extra step of correct cipher, where we provide also the context, the error, back to LLM to let him correct what is wrong. This is what our old approach. But what we have faced in this approach, we have faced many challenges. In fact, what are the limitations? We have a database with real data. It contains property name not exactly listed. For example, I give an example. We can have as a property name gender. The gender, the property, it's not saved as a gender inside the database. It's just maybe saved at GD. Or for example, nationality code or nationalities, it can be just saved as not. So the LLM is not able to interpret that nationality or this property will be mapped to not as a property name. So here we have to provide extra context, we have to provide extra description for the LLM. Another limitation or another challenge we face is the values inside our database. Some value, for example, are encoded value. What we mean by encoded value, we don't have, let's say gender, it can be male, it can be a female. We don't have male or female saved. We can have one as data saved, or we can have two as data saved. Also for document type, also maybe for vehicle type, we have some coding that describe the values. So here, if the user, he is asking about information about male, or he is asking information about travel way, he is not able to find the proper information. Or also we have some value saved in multi-language. That means we can save values either in Arabic, either in English, either in both Arabic, English, either we can save it as a code also. So here, some kind, I will show you in next slide, some kind of limitation. We are not able to construct a proper cipher. We are not able to get a proper answer. Another also problematic is the multi-hop relationship or complex relationship. Here, the LLM is not able to get extra question, or to ask extra question, or to get more detail from user in order to construct these complex questions. So many times we get silent failure. What I mean by silent failure, we have a query that pass the LLM, that pass the mem graph, but with no result and with no explanation and with no error. Nothing happened, just no result returned. So to better illustrate this failure case, I'm going to explain some basics of the example that we have. For example, the user can ask about, give me the person that are all male, or what are the number of the person that are all male. So the LLM is able to generate a proper cipher query, but he is able to set this property p.gender equal male. The database, however, don't have this male entities. It has just one, it has two, or something like that. This is just example of one property that we have, but in our database, we have more than 100 properties that have encoded data. So this cause empty result, silent failure, no result, which is wrong in our cases. Another failure, for example, we can ask, give me the person who travel by land. So here we are asking about a travel way. The travel way also can be also either encoded, also it can be, let's say, land translated to car in the database, or it can be translated to by fly, or it can be by chip. So here we need some synonym of this value that really exists inside the database. So the LLM with this basic approach is not able to exploit what is existing inside our database. Also, for example, more complex query, give me the employee the, at the Dubai-based company who own a car. So here we can see that we have more than one node. We have company node, we have vehicle node. Also, we have node located, and we have also the address, because the location is saved in the address node. We need more relationship as has or own some vehicles, and all this the LLM is not able to construct this complex. He need more clarification from the user. So that's why we think about updating this approach. So we find a best way to do that is to use the MCP-based approach architecture. So here I'm going to more speak about this integration and how the LLM, um, the MCP-based approach solves the issue that we have just faced.
Okay, thank you. Let me share my screen and start. I hope you guys can see my screen.
Yes.
Okay, so my part is about MCP, how we have integrated and all that. Let me start. So MCP is a standard way for AI apps to connect to tools and databases, just like a universal connector. It gives AI a common language to interact with different systems. With MCP, any tool can plug in into an AI agent easily without custom integration. So this slide shows how the MCP architecture, where the user's query is handled by an agent through repeatedly interacts with MCP tools and resources to refine the results. The agent loops through available tools, calling the MCP server wherever needed, and continues retrying until it reaches a final or valid outcome. It keeps on repeating, as you can see the loop here, it keeps on repeating until it reaches a final valid outcome. This makes the system more robust, modular, and capable of handling complex queries correctly. So here MCP is a common communication standard that lets AI applications connect to different tools easily. You can think of it like a USB-C port, one connection work for everything. It helps that apps, IDEs, and AI tools talk to databases, files, and services smoothly. As in the middle, you can see it has MCP standardized protocol. On the left hand side, you can see AI applications which had chat interface, IDs, and coordinators, other AI applications. On the right, there are data sources and tools where we have data and file system development tools and productivity tools. This slide explains the three parts of MCP. The host, which has been highlighted in yellow, it is the main AI app that manages everything. The client, shown in blue, connects to different MCP servers, and the server provides tools and functions that AI can call. The LLM decides which tools to use, making the workflow dynamic and flexible. So this slide This slide shows how our MCP-based system works end-to-end. The user sends a query, the MCP client gathers tools and content from the MCP server, and the LLM decides which tools to call, like Cypher execution or validation. This cycle continues in a loop until the system has enough information to produce the final answer. As you can see, the flow, it works like that and gives the proper answer. Now, this slide highlights why we choose an MCP-based architecture. MCP gives us dynamic tool discovery so that LLM can pick the right tool at runtime instead of relying on fixed logic. It allows support, sampling, and elicitation, which I will discuss in the next slide, which means the system can communicate between LLMs and even ask for clarification when needed. Most importantly, a lot of reasoning like query validation, correction, and value inspection happens directly on the MCP server, allowing us to keep every query within 7 to 8 reliable reasoning steps without failures. So, what is sampling and elicitation? Sampling means picking only the most relevant pieces of data from the large database, so the AI agent gets the right context without being overloaded. And as far as elicitation is concerned, it is when the system asks for more information or clarification after an error, allowing it to refine the query and generate a better result. It is something like the requesting input from the client. Example of handling encoded files. The slide shows why MCP helps us handle messy real-world data. LM usually assume whether whatever user says, like mail, it exactly how the database stores it. But in reality, the DB may use codes like one or two for male or female respectively. This causes silent failures when the query returns zero results. With MCP, we use value inspector tools that checks how values are actually stored in the database, so the LLM can automatically correct the query to the right format and get the results. So the slide shows how MCP helps with multilingual and aliases values in the database. A user may say Beirut, but the DB might store it in Arabic, English, or even a keyword like BEY. The MCP value inspector returns all valid variations, and the LLM automatically rewrites the query to include all of them, ensuring accurate results. This slide explains how MCP helps with multi-hop queries, where the LLM needs to follow multiple relationships in the memgraph. MCP tools can inspect the schema, find the valid relationship paths, and guide the LLM through multi-round reasoning to build the correct traversal. If the intent is unclear, clarification loops help the system ask follow-up questions like whether the user means people working at the company or people connected to someone in the company. Thank you. I will now hand it over to Ma'am Rida, who will walk you through the next part.
You see the screen, right?
Yes.
Okay. So here is our MCP-based approach. So what are the basics or the interest of we are making the client more dynamic. We are looping over the client in order to provide to pick as many as tools to answer the questions. So and for sure we have a limit how much time you are looping. We can't loop for infinite way. So we define a maximum number of looping that we can have inside the client until we pick up the right tools. So this is just one point about looping. We don't loop over infinity. So, and here also one more value. We add this tools as a value inspectors. We add also tools as a more schema explorer or more relationship explorer. We provide a deeper understand of the user question in order to generate for complex query correct cipher. So by using this approach, here a comparison what was the old approach and what this new approach bring. So in terms of integration, at every time we have to add some let's say extra handling, we have to do that manually to define the prompt, to hard code it inside the code, to define the workflow manually, and so on. So using MCP-based approach, we don't worry about that. We just the MCP server we register as a tools, and here we let the client, the LLM, pick dynamically this right the tools. And also for reasoning, first we define our workflow. So the reasoning is limited by using self-contained reasoning or dynamic tool selection. The reasoning will be in the picking of tools will be more flexible in this way. And also the extensibilities here is very complex to scale. For example, if we need to add any other server or any other tools or any other database, here we have to scale all things. We have to repeat all this task. We have to make all the connectivity. And MCP-based approach, it allows us to have more scalability using another server or using another tools or using defining another prompt, another resources, and so on. Also for the context handling, our old approach, the chain-based one, you are going to define the prompt, the basic prompt, and manually defining this workflow. Here, by MCP approach, we can context-rich queries. We are able to adapt or dynamically adjust the query based on the selected tools and dynamically adjust the context or make the context more informative based on the selected tools. And data handling, we don't have any glue about data information or what we have. All the approach provide a limited access to the data. Here we can have access via the inspector, via any other tools to encoded data, to multi-language data, and so on. In conclusion, our MCP approach make the retrieval more reliable. We are able to handle our messy real world data like encoded, like alias. If you have some synonym data don't really exist in the user question, we are able to solve the multi-language properties and multi-language values. Also by reasoning, here we are able to provide more dynamic discovery, dynamic reasoning, many iteration until we get some valid or some correct values until some limit. So for sure we are not looping for infinite time. We define a number of looping, but via correct tools pickup, we are able to find the value that we are looking for. And for sure, the silent failure, when we don't have, when the LLM provide no answer at this time, we don't stop. We try to explore our data. We try to more clarification to see why we don't have some response. The system also with MCP is more flexible. It's more extendable. We can add new tools. We can add a new data type, a new prompt, also a new support and also it's for evolving graph structure. So our graph structure or graph database is not fixed. It really contain every day a new node, new properties. Until now we have around 100 of node. Later on we maybe go above that number. So this MCP approach allow to handle this evolving graph structures. So that's all from our side. We have liked to share our experiences about how we transform our architectures from workflow, from pipeline based, from chain based into more flexible MCP based approach. Thank you. And if you have any questions, we that's all from our side.
Thank you so much, both. I think you can stop sharing the screen now because I see myself and it's not pretty.
Yes, let me stop sharing. I stopped now. Where I can stop it.
Okay, there we go. But yeah, thank you so much to both of you for the fantastic deep dive into how MCP changes the way that you build rack systems and graph, and for showing what it looks like on some real graph examples or real data. But yeah, we have some questions for the audience, so we can maybe have a Q&A session right now. We're going to start answering questions, so if anybody has any more, feel free to ask away. But yeah, first question is, how do you control cost overruns?
Okay. So actually, what they mean by cost is time of costing or the number of iterating over the run. Here we really care also about the time that the user will get the response. So we define a maximum number of run. So we can looping or having a maximum number of run until finding up to 10 or up to 12. And we are able to see that at maximum you are able to get a correct answer for about eight looping or eight thinking by the models. So here, up to now, the kind of question that we have tested around 60 questions. From simple to complex. The simple one, you are able to in one shot to get the answer. It's very quick. But if you have, let's say, a very complex question, we really go up to 8 to 9 run until we find the correct answer. And also sometimes we request clarification from the user during this short time.
Yeah, and that maybe ties with the question.
Sometime, yeah. For example, if I need to give some time, sometime we can have a question, for example, until to get a result in more than 1 minute, 2 minutes. We are working on improving this time, so we don't need to let the user wait for this much time. We are trying to optimize the kind of thinking or optimize the kind of prompting to allow the model to pick directly the right tools to inspect the data directly in order to reduce this number of run or this timing. This is currently working step on the optimizing of the time speed up of the algorithm. So for time being, just we focus, let's say until how much you are able to get a response. Let's see what are the time and do we really get result. If we get result, next step, let's try to optimize this thinking, this pickup of the tools, this timing, what we can achieve. We are working on that right now.
And how do you know when you get the desired result from the loop?
Yeah, exactly. When do you know here what we have do for testing? We have prepared a list of questions. And for the list of questions, we know what is the correct cipher. So we have about 100 questions we know the correct cipher that is generated, and we know the answer that is generated. So an old approach, we are not able to tackle the complex one, either the simple one with encoded values. We are not able to have this kind of result. Um, we use this testing. We can say we have this testing data. We try this question on the old pipeline. We try this set of question on the MCP-based pipeline, because we know what is the answer already prepared by another by our team, by other memgraph teams of our at Orbis also. They define for us a list of questions. They define a list what are the corresponding cipher and what are the results. So that's why we are able to know that the desired output.
Okay, that makes sense. Thank you. We have one more question from the same user, but I broke it down because it's a big one, so you won't be able to see. But the question was, have you considered multi-shot learning by tracking cipher across multiple requests in order to improve results?
Exactly. So here, yes, we have memory, and we keep track of the cipher over multiple requests to improve result for sure. So for example, if we have a cipher don't return result, this cipher will be tracked again. It will be inside. We have, if we a list of generated cipher, a list of possibly generated answer, a list of pickup tools. So we pass all this as a context for the model to avoid also to generate the same one. This is didn't give a result, so we are not. So the model will learn that it's not giving a result. He is not generating the same again. So he is going to try another approach for learning. For sure, yes, we track that.
Yeah, okay. We have one more question. So this one is, during your testing, did you try different LLMs? And if any worked better with this approach than the others?
Okay, so this is a good question. Really, LLM model have money performance, how they behave. Actually, just we try two LLM. Yeah, we try ChatGPT, OpenAI, and we have DeepSeek V3 version locally, our server local. So we are working directly on our server local because we don't have access to the internet outside. So we have to use this LLM. So we try to optimize our approach for this local server deployed there. So we can't, but for testing, for sure, we explore multi-LLM. Yes, we have different we get different cipher generated by different LLM. So that's why knowing which LLM we are going to use at the end is very important in order to optimize our approach for a specific one. So everyone, mainly they may have the same prompting approach, they may have the same logic, but sometimes the cipher generated or the response or the pickup of the tools may differ from one to another. We experiment that, yes.
Yeah, makes sense. Whenever we have a topic regarding RefRag or AI in general, one question is always for sure, like, what are the differences between LLMs? So that's our standard question.
Yes.
Okay, yeah, one more question. What are the biggest technical challenges transitioning from traditional RefRag system towards MCP-based system?
Transition. You mean the biggest technical from
Oops, you froze.
I'm thinking the question as regarding the transition. What is the challenges we face for the transition? So actually, these are two different, if we say two different approach. We have the workflow. We define where to go. So here is a state. We define the state of the system. An MCP-based one. we change completely this kind of thinking by defining a client, by defining the server, moving all, if we need all the workflow to be like a tools, and also the logic of the client. He has to pick up all the tools. So here's a transition, mainly technical. We need to change all the thinking how it works. It's not just straightforward. Just we have to redefine everything. Even the core functionality remains the same, but the prompting, also the client itself, the logic. So if we need to say the logic of the client, the MCP client, this is the biggest challenge. So how the client should iterate over tools, for how much, how to know if you get the answer or not yet, where to stop, if this is a good tools or not. So the logic, the business of looping inside the client, this is mainly a challenge within the MCP. And also another point, the elicitations. So we try to improve the elicitation approach, when to ask the user to get these questions, to get the answers, to provide clarification. Here some technical stuff we may face about defining the logic, the elicitation approach. So we can say that this is the biggest technical challenge.
Yeah. And maybe one last question. If anybody has any more, feel free to ask away. But how does evaluation look like for you in production? How do you determine a good versus bad LLM reasoning chain?
Okay, here we haven't yet go into the production. We tested locally. What I mean locally, before production, we have testing phase and a real test environment with the real person, and we have really, for example, we can say in old approach, as we are able to get, let's say, 20 correct question out of 100. With this new approach, we are able to get 90%, 90 of the question over 100, which is typically the good value that you are looking for. So we need to handle as much possible around 90% of the question. So this is the first testing set that you have, 100 of the question, from simple, very simple, basic question to more complex. And we are able, as I told before, to test that because we know the answer. So we know what is the cipher, we know the answer. So we are able to have this. Maybe later on, based on the evaluation of the database, we are going to explore more set of question and see how much we are as a result, or does this accuracy will remain, does it drop, how to improve it over the flow. So this is mainly to be tested further. We are on the beginning of developing this approach. We developed something more accurate. Now we are scaling it, we are improving it to get the reduced number of the time, and also uh, we are uh, we are working on getting more questions, more set of question, and we need to test on this new set of questions.
Yeah, that makes sense. We have one more question from John. So how about the message passing from one MCP to another, and also bloat of connections when needed to group MCPs in one application or experience?
Okay. Okay. So for time being, we have one MCP client and just we have one MCP server. So here for simplicity, we haven't we haven't experiment. So our application is very, if you can say, is very basic. We don't have yet multiple MCP servers. So we didn't have this connection between this multiple MCP server. If I'm wrong, so Here also, if Affan, if you have any comment about this question, because you work more on the integration of the MCP one, if you can answer it. But till now, just we have one MCP client, we have one MCP server, and this MCP server have multiple tools.
Yeah, exactly. At the moment, we have one MCP client and one MCP server. We are working on a simple scenario at the moment.
Mhm. Okay, that makes sense. I think that's all for the questions, if I'm not missing any. But yeah, if that's it, yeah, John said it makes sense. So I guess that's it. So I think we can wrap up now if there are no more other questions. To everyone who joined us, thanks for being here and thank you for the engagement and all the questions you had. The recording will be available on Members on Demand page. I already sent a link to that in the chat. So if anybody missed this or they would like to rewatch, feel free to do so. Yeah, thank you everybody for joining us and nice messages. What I want to say, yeah, I wanted to say if you're building anything with Memgraph or MCP, we'd love to hear about that. Feel free to join our Discord where we can chat more, and I can send over a link to join our Discord server. Okay, just sent it. Thank you again, Rida and Affan, for the amazing presentation. I hope everybody enjoyed, and I hope everybody has a great rest of the day. And I guess I'll see you on our next community call. Thank you.
Thank you.
Thank you.
Goodbye.
Thank you. Goodbye.
Bye, everyone.